Okay, question 19. We have 3 points, A, B, and C. A is at -5, 3.5. So remember, if we have an x, y coordinate, the first coordinate is for the x-axis. So we go to -5 on the x-axis, which is here, and then we go to 3.5 on the y-axis, 1, 2, 3.5, and this is where A is. Okay? Do the same for B. B is at 1, 0.5. So 1 on the x-axis and 0.5 on the y-axis. It's here. And then C is at -6, 6. So we got to go over -6. 1, 2, 3, 4, 5, 6. Here's -6. And then down 1, 2, 3, 4, 5, 6. Here we are. Okay? So that's C, -6, 6. Now we want to find all these lengths, right? We want to find the length AB and AC and also CB. Okay, so let's do the length AB first, and let's remember our length formula. So if we have 2 points, so sorry, this is a -5, 3.5, right? So let's see, A is here and B is here. Then to find the length, we just make a Pythagoras right angle triangle, right? And so the length of this, so this is we can call this as XA, and this is YA, so the X coordinate of A and the Y coordinate of A, and then this is XB, and this is YB, the X coordinate of B and the Y coordinate of B. Okay, this height here is going to be Y of A minus Y of B. And then this here is going to be X of B minus X of A. Okay, and it doesn't really matter if you say YB minus YI. It's all going to work out because we know in Pythagoras' theorem, we're going to square it. So it won't matter. Okay, so to get this length here, so this is the length here, and this is this length, then we know by Pythagoras' theorem, it should just be this squared, this side squared, plus this side squared. Will be, this is, what are we going to call it? This is AB. So we'll have AB squared will be equal to this squared, so YA minus YB squared plus XA minus XB squared, and should all have a square root. Oh, sorry, no square root because we have a square on this side. Okay, so the length AB is going to be the square root of y minus YB squared plus XA minus XB squared. Okay, so now we're just going to sub in the values, right? So YA was 3.5, YB is 0.5, XA minus 5, XB is 1. Okay, so we have 3.5 minus 0.5 is just 3. So we have 3 squared minus, oh sorry, this is a plus in the middle, right? Plus minus 5 minus 1 is minus 6. It's going to be squared. So then this will be equal to 3 squared is 9, plus 6 squared is 36, which is going to be the square root of 45. 45 is 5 times 9. And we can do this with square roots, right? We can, like this, times this. So we should have 3, sorry. So this will be equal to root 5, which is just root 5. You can put it in your calculator. And the square root of 9 is 3. Right? So this is 3 root 5. So this is the length AB. Okay? Now if we want to get the length, so that was length AB that we did, right? Now if we want to get the length AC, we're going to have a similar equation, right, as this Pythagoras' theorem. We just have to get the x and y from A and C instead. So A is minus 5, 3.5, and C is minus 6, 6. So let's write this down here. A is minus 5, 3.5, and B is minus 6, minus 6. Okay, then, sorry, not A and B. We did A and B, A and C. A and C is what we want to do. Okay, so the length AC is going to be the square root of the difference of y's, so yc minus ya squared, and then the difference of x's squared, and like this. So yc is minus 6, ya 3.5, xc is minus 6, xa is minus 5. Okay, you have to be careful of the minus signs here. And it's all square rooted. Okay, so we have, okay, minus 6 minus 3.5 is going to be minus 9.5 squared plus minus 6 minus minus 5. So we'll have minus 6 minus minus 5 will be plus 5. Okay, so we have minus 9.5 squared plus minus 6 plus 1 will be minus 1 squared. Okay. Okay. To do 9.5 squared, let's just do it at the side. Yeah, 9.5 by 9.5. So let's do this. 5 by 5 is 40, is 25, and carry a 2. 5 by 9 is 45, plus 2 is 47. And remember, when we want to know how many where the decimal points should be, we say, okay, there's 1, 2, so then we need 2 here. 1, 2, so it's here. Okay, now we do the 9. So we put a 0 here. 9 5s is 45, carry a 4. 9 9s is 81, and 4 is 85. Okay, so we get 5, 7 plus 5 is 12, carry 1. 5 and 4 and 1 will be 10, carry 1. 8 and 1 is 9. So we have 90.25. Okay, so back here we'll get 90.25 plus minus 1 squared is 1. So this will be the square root of 91.25. Okay, and for this, we're just going to put it into a calculator. And if you don't have a calculator, you can just leave it like this for now. So 91 point, okay, sorry, square root of 91.25 is 9.5524, etc., etc., etc. Okay, so then the final thing we have to do is the length BC So we remember that B is all the way back up here. B is 1, 0.5, and then C is minus 6, 6. So it's 1, 0.5, and C is minus 6, minus 6. So again, the length, BC, is the square root of difference of y's, yb minus yc squared, plus the difference of x's, xb minus xc squared. So yb is 0.5 minus yc, so minus, and then yc is minus 6. Okay, xb is 1 minus, and then xc is minus 6. Okay, so we have 0.5 minus times minus is plus 6 squared, and then here again we have a minus times a minus. Sorry, this bracket should be clearer. So we have 1 plus 6 squared, and this is the square root. So this will be 6.5 squared plus 7 squared, and all still under square root. Okay, so let's do 6.5 squared over here. Okay, 5 times 5 is 25. I'll put a 2 up here. 5 sixes is 30, plus 2 is 32. Now we put a 0. 6 fives is 30. 6 sixes is 36, plus 3 is 39. And remember, to see how many decimal places we should put, there's 1, there's 2, so we should do 1, 2, it's here. Okay, so we have 0, 5, 2, and this will be 42. Okay, so this should be here equal to 42.25 plus 7 squared is just 49. So when we add them, we will get 81.25 square root. Sorry, 91. Right? 91.25. Okay, so this is the length, BC. Okay, let's see what the next question says. Okay, show that ABC is an isosceles triangle. So, an isosceles triangle, has either two sides the same or two angles the same. Sides the same and two angles the same. What we see in ABC, right? Both of the last two things we calculated were the square root of 91.25, right? So this was AC. AC is square root of 91.25, and also CB is the square root of 91.25. So AC equals CB. Okay? So ABC is isosceles. Yay, that was easy. Woohoo! All right, let's see what the next one says. Find the midpoint P of AB. Okay, so we want to find, here's AB, and the midpoint here. So the midpoint is the midpoint of the x's and the midpoint of the y's, right? So let's do this down here. Let's remember what A and B are. 5, 3.5, and 1, 0.5. Okay, we've minus 5, 3.5. This is A. And B is 1, 0.5. Okay, and we want the midpoint. So we can draw some A and B. Then this should be halfway between here and here. And one way of thinking of halfway, right, so this is the y value. right? One way of thinking of halfway is that it's the average between them, right? Like if you want to say what's the halfway between 17 and 21, then you can just do 17 plus 21 over 2. Why did I make this hard for myself? This is 38 over 2, which is 19, right? So this is just an aside, right? So the midpoint is you just find the average value for the x's and the average value for the y's, right? So for the x's, you're going to find this halfway point. So you're going to get the average of the x's for the x value, and the y value is going to be the average of the y's. So if we write this as a formula, it's going to be xa plus xb over 2, and then ya plus yb over 2. Okay, xa is minus 5, and xb is 1. So we have minus 5 plus 1 over 2. Then ya is 3.5, yb is 0.5. So we have 3.5 over 2. Minus 5 plus 1 is minus 4. 3.5 plus 0.5 is 4. We're still over 2. Minus 4 over 2 is minus 2. And then this is 2. Okay, so this is the midpoint. Okay, and if we look at this, it looks about right? It should be about minus 2, 2, which is actually exactly where we drew it. Okay. Okay, P is the midpoint. So we want to find the length PC. So this is P. PC. So here's C. Now we gotta find this length. Okay. So we can just use the formula that we have before, or because we know this is an isosceles triangle, right? So if I draw this here a little bit more clearly, here is the midpoint, and because this is isosceles, we know these are right angles, right? So this is P, B, and C. We have this length, right? CB, it's the square root of 91.25. This length is just half the length of AB, right? So the length of AB was 3 square root of 5. So this can be written as 3 over 2 square root of 5, right? And this is a right angle triangle. So one way of finding the length is to use Pythagoras and find this length. Or we can just use the normal length formula. Let's use the normal length formula because I don't really feel like dealing with this fraction and also this, right? It looks kind of harder than just doing, right? So P is minus 2, 2. And C is minus 6, 6. That seems much easier to use. Okay, so let's find PC. So we have minus 6, 6. That's C. And P is minus 2, 2. So again, the length formula is the difference in y's. So this will be yp minus yc squared plus xp minus xc squared. So yp is 2, yc is minus 6. Okay, and then xp is minus 2, and then xc is minus 6, so minus 6. Okay, and fill in this. Okay, so here we have 2 minus 6 is plus 6 squared plus minus 2, okay, minus 6 is plus 6 squared. So we will have 2 plus 6 is 8 squared, and minus 2 plus 6 is 4 squared. So we'll get the square root of 8 squared is 64, 4 squared is 16. And we add this, 6 and 4 give us 10 and carry a 1. And we'll get the square root of 80. Okay, and we'll just leave it like that.